Okay, this is example 13 on the Worded Examples files. Okay, it's the question on breath testing and blood testing drunk drivers. Okay, I'm going to use a Venn diagram so it makes it easier for you to understand what's going on. Okay, and show you the different ways of solving. Okay, the first part of the problem says, what's the probability that the suspected driver is given a test? Okay, well, let's just firstly fill out this diagram. We know that 40% are given blood tests, 81% are given breath tests, and at the start of the question they tell us that 25% are given both. Okay, so if I know that 25% are given both, well then 40% take 25%, I know that 15% are given a blood test only, and 81% take 25%, I know that 56% are given a breath test only. Okay, so that gets filled out quite easily. Okay, so what's the probability the suspected driver is given a test of some sort? Okay, so the probability of getting a test of some sort. Well, using the Venn diagram, it's really easy because you just go, oh, well, the probability of getting a test of some sort would just be 0.15, 0.25, plus 0.56. That adds up to 0.96. Okay, so really easy using the Venn diagram. If we didn't have the Venn diagram, okay, or I mean we do have it, but you can use the addition rule. You can say, well, the probability of getting a test of some sort is really the union, isn't it, here? So it's really the union. And the addition rule says the union of A and B is the probability of A plus the probability of B subtract the intersection. Always got to subtract that intersection, it gets added twice. Okay, so that would mean this, wouldn't it? That would mean I'd go, right, the probability of A, let's call A blood here, well, that is 40%, isn't it? It's 0.4, plus the probability of B, which is 81%, subtract the union, which is 25%, okay, and that will give you the exact same answer, which is 0.96. Okay, 96% are given a test of some sort. Okay, part 2 asks us to find the probability of exactly one test. Alright, exactly one test. So, using the diagram you can see, alright, probability of just one test, it's pretty easy, isn't it? Of just one test and not both, so I can't consider that. It's just going to be 0.15 add the 0.56, that gives me 0.71. Okay, 71%. Okay, but can you also see that we can approach it differently? So we know that the union of the two events still contains the intersection. Okay, we know the union of the two events still contains the intersection. So if we subtract the intersection from the union, that'll give us the same answer. So the probability of one test, okay, can also be found by subtracting the intersection from the union. So the intersection from, so we worked out the union was 0.96, the intersection is 0.25, so therefore, same answer. Probability of getting one test is 71%. Easy as. Okay. Part 3 asks, what does it ask for part 3? What's the probability that there's no test? Well, you can just use, for no test, it's the probability of them getting tested, isn't it? I mean the complement, sorry, of the probability of them getting tested. So you can just do 1 subtract the probability of getting one test. Okay? So therefore that's going to be, what do we work out for one test? It's 1 take 0.71. That gives us an answer of, well, actually sorry, not one test, it should be the probability of them being tested, not one test, so it's 0.96, I take that back. Okay, of course, so the probability of them getting no test is 1 take the probability of them getting tested, which is 1 take 0.96, which is 0.04. Okay, so 4%. So that would be, up in your Venn diagram, that's represented here, isn't it? If that's all the testing, then probably not getting a test is 0.04. Okay, Last part of the question, have I got any paper here? I do. It says, are giving two tests independent? How to work out that? Okay, so how giving the two tests independent? Well, you just use this rule, okay? If they were independent, then the probability of both tests, okay, the probability of both tests would equal probability of, what was it, blood times the probability of breath. Okay, if they're independent. So this would be 0.81 times 0.4, and that gives me 0.324. Now, that gives me an answer of 0.324. But you know at the start of the question, we were told the probability of getting both tests is 0.25. So, probability of blood multiplied by probability of breath does not equal the probability of both in home. So therefore, they are not independent.